Okay, so this is the question for B plus trees. So we're given this table with a name, years, age, and price, and we are told that we have built an index over the years, age, price, and that is 2 levels deep. So that'll look something like this. And then this is our leaf node. And then we're told that data is stored by list of references in separate data pages, each of which can hold hundreds of records. Okay, so for part A, we're given this query, and we're asked, what's the worst case number of page IOs to execute this query on an uncluttered index? There's 1, 2, or 3 matching records. Okay, so firstly, what we want to do is we want to read down in our index. And so we note that this would take an IO to read, then we follow it down. Okay, so now we read our corresponding leaf node index. And then this points to our data page. And so if we only have one matching record, then we would just read in that corresponding data page. And what each leaf node looks like is it'll look something like this, where this leaf node equals to this data page that has like 1, 2, and then this would be a list of pointers. And so note that for each matching record, because it's unclustered, we would have to read a separate page potentially. And so to read our B plus tree, we first read 3 to get to the corresponding data page or corresponding leaf node, which holds where our data page will be. So we have 3 for the B plus tree. And then for each matching record, we have to read in that data page for that record. And so for one matching record, we'd have to read 3 plus 1. For 2, we'd have to read 3 plus 2. And for 3, we'd have to read 3 plus 3. And so that would give us 4, 5, and 6. So that would be the worst case, because for the worst case, each of these matching records are on separate pages. Okay, so now what is the worst case number of pages needed to execute this query on a clustered index if there's 1, 2, 3 matching records? Okay, so as we said before, to index through the tree, that's 3 page IOs, right? And now since the index is clustered, records are stored next to each other on pages, or at least semi next to each other, given that it is roughly sorted. And so what we have here is that for one matching record, we'd have 3 plus 1 because we're good. However, for 2 matching records, initially, we would think, oh, they should be on the same page. But there's a caveat. There's no guarantee they won't cross a page boundary. So these are, let's say, pages that are next to each other. And so since they're roughly sorted, let's say we're looking for the key value of 1. So your key value is 1 here. But it might be at the end of a page, and your next one might be at the beginning of a page. So in the worst case, for 2 matching records, it would be 3 plus 2, because you'd have to read in this page. And since our record is near the end, we'd also have to read in this page since our record is at the beginning. And so in the worst case, for even a clustered index, 1 would be 4 and 2 would be 5. But for 3, our worst case would still be 3 plus 2, which would be 5, because we know that it'd be here. And this is because we are told that each can hold hundreds of records. Each page can hold hundreds of records. So this is the last one, but then we know for sure that this, the third record should be on the same page as the second. Okay, now for part C. Now we're told to select from fine lines where price equals to 100. Okay, so here we have to check what is our index over. Well, our index is, we're told, is over years, age, price. So this query doesn't actually match our index. And so if we have 150 data pages, we just have to read all of them because our index doesn't help us in any way. So for this, 150. Now we're told to delete from find lines where years, age is 1 and price equals 5. And we assume that this deletion deletes exactly 1 record. So how many page IOs are needed to execute this query? Okay, so if I'm going to redraw our tree, something like this. Okay, so it deletes exactly 1 record. And so first we have to look through our B plus tree, which we established is 1, 2, 3. And this is then would tell us which page we have to read in. So first, we have to read our B+ tree. And then we have another one, and this comes from reading our data page. And now we're told we want to delete from. So what is deleting? Well, that's updating or writing into the data page. So we have another IO from writing the data page. And then what we have to do now, which is a little different from what we're used to, is that we have to change whatever we did in our index as well, because we want to keep our index updated. So because we deleted this record, now we don't want that in our index. So for example, if it was like 1 and then it was a pointer to this page. So if instead this is what our leaf node looks like, and this is our data page that we read. Let's say it's something like that. So now that we have written to it, and by writing we mean deleting, so now we've deleted that record, we don't want to store this pointer anymore because that record is now deleted. So we actually have to have another write to write into our leaf node page, because we have to delete the key from our index. Okay, that's it for this question. If you have any questions about it, feel free to write on Piazza and ask there. And yeah, that's it for me.